Unit 2.2, we do practice. The energy required to separate the ions in the magnesium hydroxide crystal lattice into individual magnesium and hydroxide ions, as represented in the table below, is known as the lattice energy of magnesium hydroxide. As shown in the table below, the lattice energy of strontium hydroxide is less than the lattice energy of magnesium hydroxide. Explain why in terms of periodic properties and Coulomb's law. So before we dive right in, there's a few things that we should highlight to make sure that we're answering the full question when we're finished. So a lot of this question is background information, but this very last sentence is important. We need to explain why our lattice energy for strontium hydroxide is less than the energy of magnesium hydroxide, and we need to do so in terms of periodic properties and Coulomb's law. So we need to make sure that we're specifically referencing periodic properties and Coulomb's law in our explanation. So first we can explain this difference in these lattice energies using periodic properties. So if we take a look at our periodic table, we're going to notice that magnesium is higher on the periodic table or higher in the group than strontium is. This means that strontium has a larger ionic radius than magnesium does because it has more occupied energy levels. And now to tie in Coulomb's law states that the greater the distance between charges, the weaker the attractive force. So in this case, if strontium has a larger ionic radius, strontium and hydroxide are going to be farther apart, so their attractive forces are going to be weakened. Whereas magnesium has a smaller ionic radius, so it and hydroxide are going to be closer together, so it's going to have a stronger Coulombic attraction. And finally, ultimately, the weaker the Coulombic attraction, the weaker the lattice energy, the stronger the Coulombic attraction, the stronger the lattice energy.